Hello, in this video, we will look at class relationships. To design classes, you need to explore the relationships among classes. The common relationships among classes are association, aggregation, composition, and inheritance. You have already used inheritance to model the is-there relationship. We now explore other relationships. First, association. Association is a general binary relationship that describes an activity between two classes. For example, this student course, student takes a course. Faculty teaches a course. You can put a label on this line linking these two classes and use an arrow to show the direction. So this is student takes a course, and this is faculty teaches a course. You can also put the multiplicity, the range here. This is between 5 and 60, means a course can have between 5 to 60 students. And this is hypothetically, student can take any number of courses. But here, this faculty teaches between 0 and 3 courses, and course is taught by one faculty. When you translate the association into class, you can use this method to perform an action here. For this student here, student takes a course. So this is add a course to the list for the student. And this is the course. Course has this, add a student into the course, set a faculty who teaches the course. For the faculty, add a course to the list of the courses faculty teaches. Let's look at aggregation and composition. Aggregation is a special form of association that represents an ownership relationship between two objects. Aggregation models has a relationships. The owner object is called an aggregating object, and its class is called an aggregating class. The subject object is called an aggregated object, and its class is called an aggregated class. Association is a special form. Aggregation, it's a special form of association. Composition is a special form of aggregation. We refer aggregation between two objects as composition if the existence of the aggregate object is dependent on the aggregating object. In other words, if a relationship is composition, the aggregated object cannot exist on its own. For example, look at the student has a name. This is the composition. Name cannot exist without student. Student has a name. So this is aggregation, but furthermore, it is composition. Student owns this name exclusively. This right here, student has an address. Address can exist without student. So this is aggregation, not composition. In the UML diagram, we use the solid diamond to represent the composition, and this is the hollow diamond for aggregation. Now, when you're translating this to classes, whether it's aggregation or composition, it's been translated in the same way. So now, many textbooks don't distinguish composition and aggregation. So they call it all together as composition. So that's fine for simplicity, and we'll do that too. In this book, in the future, we just call the relationship is composition, it may be aggregation. That's just the way it's traditionally, it's been done for referring the has-their relationship. So now when you're translating this relationship, composition, and aggregation, you can see this is pretty much the same. For name, so this is name. For address, this is the address. For student, so you have the data fields for name and for address. So they're treated the same way. Now, a class can have a relationship with itself. So for example, this person is a supervisor for another person. So a person may have multiple supervisors. So this is the diagram. So you can have this person has one supervisor. So if you have multiple supervisors, you can do that too. In the future, we can have a list for that purpose. So again, this is the note here, because aggregation and composition relationships are both implemented in classes in similar ways. For simplicity, we refer both as composition. That is all for this chapter on class relationships. See you on the next video.